Here we are going to solve certain questions based on heights and distances chapter. So the heights and distances chapter mainly has the angle of elevation and angle of depression. Just we need to know how angle of elevation and angle of depression are looked and formed, and thus we can solve this question. So I will just see what's given in the question. The question says a tower stands vertically on the ground and from point on the ground which is 15 meters away from the foot of the tower. So here we have to consider a tower which is standing on the ground, which is 15 meters away from the foot of the tower. So the angle of elevation of the top of the tower is found to be 60 degree. So this is the tower. Let's consider a tower as A, B, which is perpendicular to the ground and which is 15 meters away from the ground. So AB is the tower which is 15 meters away from the ground, and the angle of elevation of the top of the tower is 60 degree. So we have to find the height of the tower. AB we have to find out, which is question mark. So here first of all we will write the given part. Let us consider. So here just first we have considered AB as a tower, and angle C and angle ACB is equals to 60 degree, and which is the given part, and BC equals to 15 meter. So here in triangle ABC, which is right angle triangle, here it is a right angle triangle and we are given the angle of elevation means the angle ACB is given 60 degree and we are given BC. So here you can see that we are given a adjacent side and we don't know the opposite side, and the angle is given. So opposite upon the adjacent, which is nothing but tan angle. So tan of 60 degree, angle of elevation also we know. So from here we can find the value of AB, thus deriving the relation as tan 60 degree is equal to AB upon BC. I will further put the values. Tan 60 is √3 and AB we have to calculate, and BC is 15 meter. So AB comes as 15 √3 units. So thus the height of the tower is 15 √3 units, and this is the required result. Now we are going to solve this particular question, and the question says kite is flying at a height of 60 meters from the level ground. So we will consider a kite which is P, which is at 60 meters from the level ground as question says, and which is attached to a string inclined at 60 degree to the horizontal. Kite is inclined and connected to a string which is inclined at 60 degree to the horizontal. So we have to find the length of the string. We have to find, let us consider O as a point where the string the string is connected, and we will consider it as M. So PM is the ground is the level at which the kite flies, and we will consider a point O which defines the angle of elevation and the string connect and the point from where the kite is connected. So which is 90 degree, and angle M is 90 degree. As from here we can conclude that. Further, I'll write the part which we have considered. Let us consider PM as the height of kite from ground. PM is the height of the kite from the ground, which is given as 60 degree, 60 meters, and further angle POM as 60 degree, which is the angle of elevation since, and we have to find the length of the string, which is OP. We have to find out. So here we will consider again a right angle triangle PMO, right angle triangle, and here also we are given an angle of elevation and we are given an opposite side. We need to find the hypotenuse side. So here we can apply the formula of trigonometric ratio, which is sin theta, which is opposite upon hypotenuse. Thus we will get the length of the string. So I will apply sin 60 degree is equal to PM upon OP, which is sin 60 is root 3 upon 2 and PM is 60 and OP we have to calculate. So OP is equals to 120 upon root 3, cross multiplying we'll get, and further if we rationalize it we get multiplying it by root 3 both again in numerator and denominator, we'll get 120 root 3 upon 3, which comes as 40 root 3 meters. So thus we have got the length of the string, which is 40 root 3 meters. Thus OP is equals to 40 root 3 meters. This is the required result of the problem. This is the next question related to the heights and distances. We'll just read the question, form the diagram, and then solve the question to get the required result. So I'll just read out. The question says an observer is 1.5 meter tall. First of all, I'll consider an observer AB, which is 1.5 meters tall, which is, and I have to consider a chimney, which is, as it says, 28.5 meter away from chimney. I will consider a chimney CD, which is 28.5 meters away. Observer is 28.5 meters away from chimney. So here we have to consider angle of elevation of top of chimney from his eye, means observer's eye is 45 degree. So observer is AB, observer's eye is this, and we have to consider angle of elevation. So angle of elevation says from the observer to the top is 45 degrees. So angle of elevation is 45 degree from the observer point, which is A to the top of chimney, which is C. So angle of elevation is 45 degrees, and we have to find the length of chimney. We have to find CD, which is question marks. This is the value which we have to obtain. And here also I will consider a point E. First of all, I will write the values which I can derive from the given part, which I can derive from the diagram. Here, to solve this heights and distances question, first you need to draw a diagram and just thus write the part which you have considered from the diagram in the question in the form of given equations. Thus I will write it as, let us consider CD as a chimney, as means height of the chimney. And AB as an observer, which is 1.5 meters tall. AB is equals to 1.5 meters. Here it is a rectangle, as you can see AEDB is a rectangle. So therefore we can say that AB is equals to ED, as the properties of quadrilateral say that in a rectangle, if two sides are parallel sides are equal. So therefore AB is equals to ED, which is equal to 1.5 meter. Now further I will write the next part, which says that angle of elevation is angle CAE is equals to 45 degree. So in triangle CEA, which is a right angle triangle, we can say that tan, so this is a right angle triangle, so here we can apply the values of trigonometric ratio, means we can apply the formula of tan 45 degree, which is CE upon AE. So I will first apply that, because I need to find the height, which is height of the chimney, which is CD. So CD, first of all I will consider it as H. So tan 45 is, first of all I will write AE upon CD. This we have to use further, and then I'll see I have to thus substitute the values in the place of AE and CD. AE, as AE is also side of rectangle, so two sides which are parallel are equal, so BD is equals to AE. So therefore BD equals to AE, which is equal to 28.5 meters. So thus I got AE. And let us consider the height of the chimney, which is H. CD equals to H. And but CD is equals to H. But here we have considered AE upon CE. So but further, if we need to find the value of CE, so I will first consider the value of CD as H and further derive values from it, as CD is equals to CE plus ED. So ED is 1.5 meters as we have calculated above, and CD is H. So we will put H is equals to CE, we have to find, plus ED is 1.5. So CE is H minus 1.5. So I have got the value of CE and AE also. So I will put it in the first equation of tan 45. So tan 45 degree is equals to AE is 28.5 meters. I will put it here, and CE is H minus 1.5. So tan 45 is 28.5 upon H minus 1.5. So I get, further solving, H minus 1.5 equals to 28.5. So further, if I take H is equals to 28.5 plus, it will go on the right hand side, minus will become plus. So H is equals to 30 meters. So we have considered H as nothing but CD, the height of the chimney. So thus we get the required result, that is the height of chimney, which is CD is 30 meters. This is the next question related to the heights and distances. So the question says as horizontal distance between the two poles is given. So first of all I have to consider two poles. So I will consider first pole as AB and second pole as CD. The horizontal distance is given as 15 meters and the angle of depression of this is the first pole and this is the second pole. So the angle of depression means from angle of depression of this pole we have to take as 45, which is given as the angle of depression top of the first pole. This is the top of first pole, which is AB, which the top is A, is seen from the top of the second pole, which is 30 degree. So the angle of depression here is 30 degree, which is seen from the top of first pole and seen from the top of the second pole. This is the angle of depression that we will consider. And then the height of the second pole is also given. CD is given 24 meters, and we have to find the height of the first pole. AB we have to find, which is question mark, and here we will consider another point E. So I will first of all just write the given part which we will consider from the diagram. First of all we will write that let us consider AB as first pole, which we don't know and we have to find out, and we will consider CD as second pole, and which is given that CD is equals to 24 meters. And here we are given the angle of depression also, and the angle which is CAE is given, which is angle CAE is 30 degree. So here we can see as here AEDB is a rectangle formed, and rectangle the properties of rectangle say that the sides which are parallel are equal. So we will write as BD is equals to AE, BD is equals to AE, and we are given that BD is equals to 15 meters. So we will write as 15 meters. So from here we can obtain the value of AE as 15 meters. Thus we can derive a relation from here, but we can derive a trigonometric relation of which is tan of 30 degree we can consider as we are given AE, and CE we can find out from here. So tan 30 degree is equals to CE, which is opposite side upon the adjacent side. We will get here 1 upon root 3 is equals to CE is we have to calculate, and AE is 15 meters. So CE comes as 15 upon root 3. We get the value of CE as 15 upon root 3. First of all I will rationalize this 15 upon root 3 into root 3 upon root 3. I get 15 root 3 upon 3. Here I get the result as 5 root 3. So here I get the value of CE as 5 root 3, and here we have to use root 3 is equals to 1.732. So further I will calculate the value of CE is equals to 5 root 3 and put the value of root 3 as 1.732. So here after solving this we have to just multiply 1.732 into 5. I get the required result as 8.66. CE, I have got the value of CE, and I have to then I can find the value of ED from here, as I have now got the value of CE, and CD I know, which is 24 meters. So CD is equals to CE plus ED. So I will put the values 8.66 and CD is 24 plus ED I have to calculate, and ED thus comes as 24 minus 8.66 ED is 15.4. So here from ED comes as 15.4, and in here also we can say that as this is a rectangle and the sides of both are parallel sides of a rectangle are equal, so AB is equals to ED, and thus AB comes as 15.4 meter, which is the height of the first pole. So thus we get the required result. This is the next question which we are going to solve related to heights and distances. I'll first of all see what's given in the question. The angle of elevation of top of building from foot of tower is 30 degree, and angle of elevation of top of tower from foot of building is given 60 degree. So first of all we are given a building and a tower. So I'll consider a building as CD, and I'll consider a tower as AB. So the angle of elevation from foot of the tower, this is the building and this is the AB's tower. The angle of elevation from the top of building, this is top of building, from the foot of the tower, this is the foot, is given, which is 30 degrees. And further, the angle of elevation of, this is the top of the tower, from the foot of the building is D, is given, which is 60 degree angle of elevation. And if the tower is 50 meters high, height of the tower is given 50 meters, find the height of the building. We have to find CD, height of the building, let's consider as H, this is H we have to find out, and the distance between tower and the building is not given, we can assume it as D as the distance. So I will just first of all write out the given part. Let us consider CD as building of height h meters. This is the part which we have assumed from the given part. And next we can assume the next given part is, let us consider AB as a tower. Let's assume AB as tower whose length is also given to us. AB is equals to 50 meters. It's already given. So, and we need to find the height of the building, which is CD. H is equals to H, which is question mark. So I'll write here CD equals to H. So here we can there are two triangles. First of all, I'll consider the triangle ABD. So from ABD, as we can say that the angle is given and height is given, we can find D, and if we get the value of D, we can find H also. So I'll first consider triangle ABD. So in triangle ABD, which is a right angle triangle, tan 60 degree you can consider as opposite side is given, and we have to find out the value of D, which is the adjacent side. So tan 60 degree is equals to AB upon BD, which is AB is given 50, BD is D, tan 60 we have to put, which is root 3 equals to 50 upon D. So here, from here we can get the value of D as 50 upon root 3 meters. We have got the value of D. Now I will consider the second part, with second triangle, which is CBD. In triangle, I will consider CBD, which is right angled. I know the value of D now. I just need to find the value of H. Tan of 30 degree. Here also I will consider tan 30 degree is equals to CD upon BD, which is tan 30 is 1 upon root 3. We will put CD is H, we have to calculate, and BD we have calculated the value as D, which is 50 upon root 3 meters. So further I can simplify and get as, I can just get the value of H is equals to 50 upon root 3 if I cross multiply, which is root 3 upon 50. I can just multiply this 50 upon root 3 into 1 upon root 3. I get 50 upon 3, which is further, if we divide it, we can get that 50 divided by 3, we can get 1, 6 times 18. So we can write it in the form of quotient into remainder upon divisor, 16 to the power 3 meters. So in this way we have calculated the value of H. This is the next question which we are going to solve. Let's first of all read the question and see what's given part and draw a diagram according to that given conditions. So first of all, the angle of elevation of top of tower is, the question says the angle of elevation of the top of tower from 2 points P and Q at distances A and B respectively from the base in the same straight line are complementary. So first of all, consider a tower. Let's say AB is the tower, and angle of elevation from 2 points at distances are given which are complementary. So I will first of all consider first angle of elevation P, which is theta, and it says that they are complementary and in the same straight line. So I will consider the second angle of elevation 90 minus theta, 90 degree minus theta, which is a complementary angle Q. So here, and this is again a right angle triangle, and we have to prove the height of the tower, which is equivalent to root of AB. So I'll consider the height as H, as this we have to find out. So first of all, I'll write the given the part which I can which I can conclude from the diagram. So let us consider AB as a tower of height h meters, and which are we are given the distances. BP is given as A and BQ is given as B. So we know BP as A and BQ as B. I will write it here. And next we have considered the tower. Now next I will consider there are two triangles. First of all, I will consider the triangle APB. In triangle APB, which is theta, and a right angle triangle, which is a right angled triangle, I will consider tan theta. I will first of all consider, because I know the adjacent part and I have to calculate the opposite side. So I will derive two equations and can simultaneously solve those two equations and get the value of H. So first of all, tan theta I will get as AB upon PB, which is I know the value of AB as H, which I have considered, and BP is A. So this is the first equation we can get. And now I will consider second triangle AQB. So in triangle AQB, which is right angled triangle. So I will consider again tan theta, tan of tan of 90 degree minus theta, which is complementary, which is equivalent to opposite, which is AB upon the adjacent QB. I'll put the values in that. Tan of 90 degree minus theta is AB is H and BQ is B, which is the second equation. Now I get the first and second equation. Now here, but we know that tan of 90 degree minus theta is, further if I simplify, cot theta is equals to H upon B. So I get the two equations, which are, I have to first simplify this, tan theta and cot theta. So I know that tan theta and cot theta are reciprocal. So I know that the tan theta and cot theta are reciprocal functions, and multiplying them I will get 1. So I can find the value of H by multiplying the two equations. So multiplying 1 and 2 I get tan theta into cot theta is equals to H upon A into H upon B. So here tan theta and cot theta have a reciprocal function, and its value is 1. So 1 is equals to H into H is H square upon AB. So I can get the value of H square equals to AB, and H is equals to root of AB. So thus this is the required part. We have to prove in the question that H is equals to root AB. Thus I have proved the result. Proved. This is the required result, and we have obtained the result and solved the particular question. So this is the next question which we are going to solve. I will first read out the question and draw a diagram out of it. An aeroplane is given when flying at an height of 3125 meter. So I will consider an aeroplane AB of height 3125 meters, which is from the ground, which is vertically below another plane. So two planes I have to consider. Vertically below another plane I will consider another plane which is flying at AC, which is height we don't know, H, and it's given the angle of elevation of top of two planes. Means the first angle for first top is of AB, which is A, and AC, which is C, is the top, and the angle of elevation are given from both 30 degree and 60 degree from the same point on the ground. Let's consider a point of observer which is O. Angle of elevation of top of first plane, I'll write 30 degree. Angle of elevation of top of second plane I will consider here, which is 60 degree. Top of second plane is given. Find the distance between the two planes, means A, which H will be the distance between the two planes which we have to calculate at that instant. So I don't know the distance from the ground to the planes. I'll consider the distance as D on the ground level, and so I'll first of all write out the conditions which I can derive from the diagram in the given part. Given, let us consider first plane, aeroplane of which is AB of height 3125 meters, which is at height 3125 meters, and I will consider second aeroplane which is vertically above the first plane at height which is AC, aeroplane as height AC, I assumed AC as H, AC as H meters, and from first I can derive that AB is 3125 meters. So first of all, and let the OB is equals to D meters. So first of all, I'll consider the triangle AOB. So in right angle triangle which is AOB, I can write tan 30 degrees equal to AB upon OB, as I know the opposite side and I need to find the adjacent side, and so I'll consider the formula of tan theta, which is opposite upon adjacent, which is AB upon OB, which is 3125. I will put upon D. Tan 30 degrees 1 upon root 3 equals to 3125 upon D. This is the first equation which I get. Now I'll consider the second triangle CEOB, which is also a right angle triangle. Again in right angle triangle, which is COB, I can again derive the formula as tan of 60 degree. I will consider, as I know the opposite, I can form the opposite side, BC upon OB. I have to derive two equations such that I can get the equations and simultaneously solve those two equations to get the height H. So tan 60 is BC upon OB. So BC I can write as BC is nothing but H plus which is AC plus AB. So I'll write H plus 3125. Directly tan 60 is root 3 equals to H plus 3125 upon, I can write OB is D. This, from this I get the second equation. So now I can see that I can just solve the two equations. So I will divide second equation by first equation. Dividing, I will get plus 3125 upon D upon 3125 upon D. So here H plus 3125 upon D into D upon 3125. So dd will get cancelled. 3 equals to H plus 3125 upon 3125. I can get here 9375. Multiplying this is equals to H plus 3125. I can get the value of H as 9375 minus 3125, which is 6250 meters. So I will get H as 6250 meters, which is the required result, which is the distance between the two planes. H at that instance is 6250 meters. This is the required result. Root 3 question related to heights and distances. We can see how we can solve the question. First of all, I read the question, draw a diagram, and then write the given values which from the diagram. The question says vertical tower stands on a horizontal plane surmounted by vertical flagstaff. This is a vertical tower which stands on a horizontal plane which is surmounted by a vertical staff. So I'll consider as the MA as the vertical tower, and which is surmounted by a flagstaff which is P. I will consider the flagstaff which stands on a vertical tower. Flagstaff of height H is given. It is given in the question. At point on plane, angle of elevation bottom and top of the flagstaff. This is flagstaff MP. Bottom is angle of elevation are given, which is alpha, and top is given angle of elevation. I will consider this as beta. Just write down the derived values so it's easy to solve the question. And then we have to prove that the height of the tower. This is the tower's height, we don't know, which is h. I'll consider it h. We have to prove that the height of the tower is h upon h tan alpha into upon tan beta minus tan alpha. So here I will consider an point of O, which is angle of elevation. We will consider observer. We can consider the points of angle of elevation. We can consider always it as O, as it is an observer. From observer's point of view, we can derive the angle of elevations. We'll look at the angle of elevation. So I'll then write the values from the diagram, given values from the diagram, given as AM is vertical tower of h meters. I'll write as AM equals to h, and PM is the vertical flagstaff. Vertical, I'll let PM is vertical flagstaff. I'll write of h meters. Again, PM is equals to h small h, and then I can consider the ground as d meters, which is OA, as adjacent side is there. So we can apply tan formulas here. So I will consider opposite upon adjacent. So adjacent I will just assign value as d. Let us suppose OA is equals to d meters. So then I'll first of all consider the triangle, which is first triangle I will consider MOA. So in right angle triangle which is MOA, I can suppose that tan of alpha I can consider here. Tan alpha is opposite upon MA upon OA, which is MA is H, OA is D. Tan alpha, I'll let it, the equation I'll write, first equation I have got. Then I'll consider the triangle POA. So in right angle triangle POA, tan beta I can write as here also opposite upon adjacent. I will derive such equations which will contain capital H also, so I can simultaneously solve those two equations and get the value H, which is we have to prove that the height of the tower here, so height of tower we have considered capital H, so I can prove from there this required result. So I need to first get that value in the equation. So tan beta is equals to PA upon OA. So I can write here PA tan beta is equals to PA is H plus capital H, which is height of flagstaff plus height of the tower, vertical tower, which is capital H, upon D. OA is G, which is the second equation. So I can here just divide first equation by second equation. I will get tan alpha upon tan beta dividing 1 and 2 upon, I will get H upon D into, I will take reciprocal as I have to divide small h plus capital H. dd will get cancelled. Dividing here I can write divide 1 by 2 first equation by second, tan alpha upon tan beta is equals to capital H upon H plus small h plus capital H. I can just solve this two equation. I can write here H tan alpha cross multiply plus capital H tan alpha is equals to capital H tan beta. So here I can just say that these two have capital H. I will take it on the left hand side, H tan beta minus capital H tan alpha is equals to H tan alpha. So here I can take capital H common as tan beta minus tan alpha is equals to H tan alpha. So I can get the value of capital H here as, I'll solve it here. Capital H is equals to H upon the bracket value I can take in division. So H upon, on the left hand side I have remaining part H tan alpha upon tan alpha minus tan beta minus tan alpha. So I have got the value of H. I'll see whether it matches the required result. So I have got the required result which I need to prove in the question. Thus I get H as H tan alpha upon tan beta into tan alpha, which is the height of the tower. Thus I have proved the, hence proved I can write. Hence proved. This is the solution. Away from lighthouse which is 100 meter high. Let's consider a lighthouse 100 meters in height and which takes 2 minutes to change the angle of elevation of the top from 60 degree. First angle of elevation 60 degree from the ground, which is given. 2 minutes to change the angle of elevation. So it must have covered some distance also, 60 degree, 30 degree, which is perpendicular. We have to find speed of boat in meters per minute. So first of all we need to find the distance covered by the boats from the tower. Let's consider tower as AB. Distance, first distance is P and second angle of elevation Q. So I will assign the distance covered by in first lap by the boat as D and second lap as X. These are the two distances. And next we have to find speed. So if we need to find the speed, I know the time which is given in the question, I need to find the distance. So I'll first find the value of x, which is the distance, and thus I can find the speed. So I'll try to find out the value of x. First write the given values, simultaneously solve the equations and get the result. So in triangle, so I'll first write the given values. Let's suppose AB as tower, which is 100 meters high. AB is equals to 100 meters, and next we can write the BP as the first distance covered by the boat, BP as D. Let us suppose BP is equals to D, I suppose, and PQ is equals to X meters. And next I will consider in triangle ABP. ABP I can consider, which is a right angle triangle. I know the opposite side and adjacent I have to derive, so I will use tan 60 here. Tan of 60 degrees is equals to AB upon BP, which is 100 upon D. So tan 60 is root 3 is equals to 100 upon D. D is equals to, so this is the first equation. In the second equation I will write in second, considering the second triangle which is ABQ. So in triangle, right angle triangle which is ABQ, I will write tan of 30 degree as AB upon BQ. So I will put the values further. AB is 100, BQ is D plus X. So I will write AB is 100, tan 30 is 1 upon root 3, 100 on D plus X, BQ's value. So from here I can put the value of D and can get the value of X. So the value of D is 100 upon root 3 from first equation, 100 upon root 3. First I will solve the equation simultaneously. D plus X is equals to 100 root 3. I will put the value of D from 1, this is second equation, so from 1 I can write d as 100 upon root 3 plus x is equals to 100 root 3. So I can get the value of x as 100 root 3 minus 100 upon root 3. So I can further solve this as 100 taking common, root 3 minus 1 upon root 3, which is 100 into root 3 minus 1 upon root 3, which is 100 into 2 upon root 3, which is 200 upon root 3. X has a value 200 upon root 3. I have got the value of x, which is 200 upon root 3 meters. So I need to find the speed of the boat. So I will put the value in the formula. Speed, s is the speed, is equals to distance upon time in meters. In meters per minute I have to find. Distance I have found out, which is x, is x upon 2 minutes I have to put. Distance I have to find in meters per minute, which is 200 upon root 3 upon 2. So 200 upon root 3 into, it will go 1 upon 2 minutes. It comes as 100 upon root 3 meters per minute. This is the result. We can further simplify it or keep it as it is. This is the required answer. I can further also simplify it as 100 upon root 3. If I have to rationalize root 3 into root 3, I will get 100 root 3 upon 3, which is 100 into 1.73 upon 3, which is 173 upon 3, which comes as, if I divide, it comes as 15 point, it comes as, I will divide 173 divided by 3, 5. 57.6 almost, it comes as 57.6 meters per minute is the final result, which is the speed of boat in meters per minute. This is the final result.